yesterday we had talked about this this pattern, trying to find this pattern and trying to use kind of what we know to help us find it. What I want you to be able to think about and compare, this is the thing that we didn't really talk about too much yesterday, is whenever I see a pattern, the first thing I do is I write the number that the term is underneath it. So I can try to compare those things because that's what I want to have happen. Okay. There's 4 operations in math that we are going to be dealing with in these patterns really heavily. We're going to be dealing with addition, subtraction, multiplication, and division. Those are the 4 things that we're really going to be dealing with. Obviously, we have powers in there once in a while, but those aren't as prevalent as multiplying, adding, subtracting, and dividing. So basically, what I want to do is I want to say, what can I do with these red numbers to make them become the black numbers? Now, what I could do is I could say, okay, well, what if I just take 1 and I subtract 1 from it, right? I could say, well, what if I take n and I subtract 1 from it? Well, I get 1 minus 1 is 0, but does that work for every number in the pattern? 2 minus 1 is 1, that's not right. So that means this can't work. I could also try to add something, but obviously I can't add anything to 1 to make it become 0. The only thing that I could really do, because again, I can't divide 1 by anything to make it become 0. So the only thing left to do is multiplication or a power, and that doesn't work either. So what you have to do is you have to use your common knowledge of these operations, right? I can't do 1 to any power to make it become 0. I can't do that. Okay, so since I can't do that, that means that I have to do something with multiplication because addition doesn't work, subtraction doesn't work, division doesn't work, so it has to be multiplication. Okay. So what I'm going to do is I'm going to line up these numbers and I'm basically going to ask the question, 1 times what is equal to 0? 2 times what is equal to 2? 3 times what is equal to 6? And 4 times what is equal to 12? That's what I'm going to try. I'm going to try to come up with this pattern. Okay. Now with that, I have basically just written what? I've written n times something equals my number, right? So n, this is n. 1, 1, 2, 2, 3, 3, 4, 4. So I've written n. So I'm looking at n times something is going to equal my number. And an is my number. Now that being said, what do I have to multiply 1 by to get it to become 0? What do I have to multiply 2 by to get it to become 2? And 3 times 1 equals 6. And then hopefully we can see the pattern, right? Now, obviously, most of you saw that the pattern went up by 2, up by 4, up by 6, then up by 8, then up by whatever. You can see that that's happening, but that doesn't help me, right? If I see that my pattern goes up 2, up 4, up 6, up 8, it matters what the last number was for me to figure out the next number, right? Could I figure out the 50th number without plugging anything in? Probably. I would just have to go 0 to 2, 2 to 6, 6 to 12, 12 to whatever, and just keep going, right? That's not efficient. In order to be efficient, I have to find a pattern. Can anyone see a relationship between these numbers? Like, how would I find this number, then this number, then this number, then this number? How do I find that one? N minus 1. If I take whatever n is and I take 1 away, does that give me 0? Sure. 2 minus 1 gives me 1. 3 minus 1 gives me 2, and so on. So this is saying that n times n minus 1 is going to give me my answer. Now, if I just test that and it works, then I found my pattern. So if I want to find the 4th term, that means I plug in 4, 1 less than 4, which is 3, and multiply. 4 times 3 is 12. That gives me my solution. This is the kind of stuff that you have to do. Okay? We'll get into way more of those examples and way more talk about those things on Monday. Okay, so we'll go through many more examples on Monday so that you can see what goes on. I just want to give you the notation for series. Okay? Any questions on this or issues or anything that you guys want to talk about with us? Okay. So now we're going to talk about series. We're just going to define what these are. A series is like the sum of a sequence. So it's pretty much the exact same thing as a sequence, except instead of commas in between it, it's addition signs. Okay. So instead of putting a comma in between each one, we're putting a plus sign in between each one. So the example that we used last time was 2, 4, 6, 8, but now it's going to be 2 plus 4 plus 6 plus 8 plus 10, whatever. If it stops, that is finite. If it doesn't stop, that is infinite. Which one employed? Sounds exhilarating. I'm glad I'm watching.
Oh, well, apparently Virginia Tech is actually the favorite.
No way.
I picked 4 in like every bracket. So.
All right. So infinite means that it would go on forever. Now the hard part about infinite means that that's going to introduce the concept of infinity. Okay. Infinity is going to be tough. So we have a way of dealing with infinity, and we're gonna have a way of actually being able to solve these things, but it becomes kind of a challenge. Okay, so just so you know, that does happen. All right, so the notation for this is, the way that you would write this is you would write so here's the notation. In the notation, you're going to use this symbol. This is a summation symbol. So that is a summation symbol. Okay, so that's like a big capital weird. In your book, it actually looks like this, and I'm never gonna draw it like this because it takes too much time. Huh? It looks like that. And the way that it works is it starts out by giving you a variable. And in our case, the variable is going to be I. So you're always going to see it from I equals 1. And then usually it goes up to whatever symbol they want it to be. Okay, or whatever they want the thing to end at. So if it says find the sum of the first 5 terms of blank, it's going to look like that. Okay, and then they'll give you a function. And that should be able to tell you whatever you need to see. Okay. So the way that you would read this is it would be the sum of the first n terms of the function. So that is the sum of the first n terms of a specific function. Right? So that is just a way that we can kind of walk through, work through whatever we need to do. But the hard part is going to be to find the pattern of these things. So the hard part is going to be finding the pattern. So if I give you a pattern that looks like this, it starts out with 25 plus 50 plus 75 plus 100 plus blah, 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 all the way up to whatever. Again, we need to find our pattern. So right here, it's a sum because there's an addition symbol in between each one. So we'd start out by writing our term 1, 2, 3, 4, and so on. So what is the pattern from one to the next? We're adding 25. Can anyone think of an actual equation that we can use that would allow us to be able to find out what the 50th term of this is? Times 50. Yes. What times 50? So what can I do to figure out an equation that would produce every single one of these things? N times 25. So I would write this out as 25n. The easiest way to think about this is I'd say, okay, I can multiply this number by 25 to get to this number. This number times 25 gets me to this number. This number times 25 gets me to this number, and so on. So if I wanted to write the actual summation notation of this, which is kind of what the end of this section is about, if I wanted to find the first infinite number of terms, whatever, of this pattern, I would write summation notation from the first term. It never ever stops, right? It goes on forever. So from the first term to infinity of 25n. So this is me saying that I'm taking the summation or the sum of the first blank number of terms from 1 to infinity of 25n. So you need to be able to read these as well, okay? But that's how we would be able to start that.
So what is the I equals 1?
I equals 1 is just saying that your first term is 1. It's saying it wants you to start at term number 1. It's the first number that you would plug in.
Okay, why did you put the infinity over this one and then over the last?
Because most of the ones that we're going to be dealing with are going to be finite, which means that they're going to stop at a number, and n is the number that they want you to stop at.
Okay,
So-
so
Correct. Yep.
For the finite one, you put the last term.
Yes. Yep.
Wait, you put like the last term or the number?
The number term it is. So I'll go through an example so you can see it. So if I said find the sum, and then let's say that we have I equals 1 to 3 of 6n. So this thing right here is basically saying, if it's asking me to find the sum, it's saying find the sum of term 1 to term 3 of this thing. So you're gonna plug in 1, you're gonna plug in the next integer value until you get to the top thing. So I'm gonna plug in 1, I'm gonna plug in 2, and I'm gonna plug in 3. So in this one, I'm gonna plug 1 in, so 6 times 1. I'm gonna add it to 6 times 2, and I'm gonna add it to 6 times 3. This number is this number. And this number is this number. So it gives you your starting number and your ending number. So the summation of this thing would be 6 times 1 is 6, plus 12, plus 18. So 6 plus 12 plus 18 is 36. So the summation of this is equal to 36. Questions on that? That's what we're gonna call it today. You do have a big ideas assignment that you can work on if you'd like to. It only includes stuff up to finding the first 6 terms of a pattern and being able to describe a pattern if it's given to you, okay? So it's none of the really hard finding pattern type questions. It's just using the entry level stuff that we talked about yesterday.